My name is Matthew Ronemous. I work at Blueflex Mobile. That was not bad. I work at Blueflex Mobile as a software architect. And today I'm going to talk about the LEGO NST robot project. Blueflex, we specialize in delivering mobile solutions to companies in the Atlanta area. For us, mobile means a lot of things. It means rugged inventory management devices. So we do some work for the Home Depot, wearables, sensors, and even robots. So we kind of work on a lot of different things there. First thing I'm going to do is introduce my robot. His name is Johnny. He's right here. Turn him on. So he has a sonar sensor in the front, a sonar sensor in the back. He has a compass on the bottom. And he has a camera lift that you could put a Wi-Fi camera on. I did not do that, but you could. First, I'm going to have him sing you guys a song. First, I have to connect him up. So this is a PhoneGap app, and it's going to talk to the LEGO NST with Bluetooth. So I'll connect. So now we're connected. Now, basically we're going to play Name This Tune. So whoever can name the tune that the robot is singing first will get a prize. So, go. Anybody? All right, well, I don't know what to do with the prize. I've got a couple, so. So that's the first part. Just play a little song. So the next part is what's happening is you can see these sensor readings at the top. They should be changing. They are. So like when you put your hand in front of here, the sensor readings change. This thing has a little bit of a delay. You see how that changed to -7 or red 7? And then as you turn it, the sensors are also updating. And then this is pressed sensor, which is true. Then the next thing is to actually drive them around. Go. All right. So that next part is to basically try to show how I built this.
So the app looks exactly like the FaceTime widget looks?
FaceTime was just so you could see the robot. The app is actually that thing that's on the side. Yeah. So first we're going to go through a little bit of history about PhoneGap. It was created by Natobi at iPhone Dev Camp, San Francisco in 2009. And then Adobe purchased it in 2011. And then that same year, they actually donated it to Apache as Cordova. So Cordova is the open source version, and PhoneGap is the commercial version. It's very similar to the relationship between WebKit and Chrome. And PhoneGap adds cloud build support to Cordova. So I have some random trivia you can impress your coworkers with. Where did the name Cordova come from? Does anybody have any idea? It's like there was a street called Cordova near the Natobi office. So that was actually where that came from. So what exactly is PhoneGap? PhoneGap wraps your HTML5 app in native code. The native code actually renders your HTML5 app within a web view. And that's essentially how your app will work on an Android device or an iOS device. The next thing PhoneGap does is it allows you to access native functionality plugins. These plugins allow you to get to APIs on the device like the accelerometer, vibration, file system, the camera. So we're going to go through how you create a PhoneGap app. So the Cordova CLI is currently how you create apps. The first thing you would do is you would call the create command, pass in a folder, which is hello, the package name that you wanted to use, and then the name of the project. And then the next thing is to add each platform that you're interested in deploying to. So in this case, we added iOS and Android. And then the last thing is to add every plugin that you're interested in using. So then you just call plugin.add or plugin add for every plugin. And then after you do all that, you'll have folders that look like this. And the www will hold all your HTML5 assets. The plugins will hold all the plugins you've downloaded. Platforms will hold the native wrappers that you created. Merges is used for overriding. So if you wanted to have different functionality in Android or iOS, you can override files with it. I really haven't used it at all. That's what it's for. The next thing is debugging PhoneGap apps. So because you have an HTML5 app, you can use standard desktop debugging, which works fine most of the time. However, plugins don't really debug because Cordova isn't actually running in the browser. It runs on the device. So what Cordova released was the Ripple emulator, which actually allows you to run in the browser and kind of simulate Cordova running. So you can have some of the plugins will work, and you can also pass in simulated data. So you could pass in geolocation data or accelerometer data and test your app out in the browser using that. And then the last option, which I would encourage everyone to always test on a device at the end, is remote debugging, which is where you're actually debugging the device directly. iOS has had excellent support for remote debugging for some time now. Recently, with the KitKat release, Android now has parity. It's pretty simple to set it up now. Previously, it was not. And then for devices that don't have KitKat on them, you can use Winery, and it's still better than nothing. It's pretty useful. It's just a lot harder to set up. All right. Now this part is about how to create a custom plugin. So the first thing is there's a config.xml file, and this exists in each of your native wrapper projects. And what it does is it gives an ID to each native piece of code that you're going to call. So in this case, we're giving the ID of Bluetooth serial to the native code column.megster.cordova Bluetooth serial. Then the next part is the JavaScript interface, which there's one of those for all the platforms. And in it, it will have a bunch of Cordova.execute, where it passes, the first thing is the ID, which lets Cordova know which piece of native code to call. Next thing is the action and the parameters. And then when you get into the native code, so we have the Java at the bottom, the class name and the package matches config.xml. You inherit from Cordova Plug-In, so it has a standard interface. You call execute, and then in the execute, it basically just uses if statements to decide which action to do on the native side, and then it extracts any parts it needs. So that is the components to set up a custom plugin. To actually publish a custom plugin, you have to have a plugin.xml file, and what this tells Cordova is what to do when somebody actually imports your plugin. What do I do? So the first thing is you tell it where to inject your JS interface. So that's the first part. The interface is always injected off the window. So in this case, you're saying window.bluetooth serial is where it's going to populate the JavaScript interface. The next thing is any changes you want it to make to the config.xml, which was what associates it with the native code. Then any files that you need copied. So in this case, there's 2 Java files that they're copying into the project. And then the last part is any permissions that you need to set. So in this case, they're setting Bluetooth and Bluetooth admin. Then the last part is you put it in the standard file structure, then you can put it on Git, or you can put it in the plugin registry, which is Cordova.io. All right, why did I do this project? Why did I create this Lego API to talk with JavaScript to that robot? First thing was to teach my kids programming. My son has been using the Lego NXT for a while. He's been using the graphical programming interface, but I wanted to actually teach him a real-world language, but use the interest that he had in the robot. So that was why I started working on this in the first place. The second thing was I tried to learn some new technology while I worked on it, and then just to share PhoneGap knowledge with the community. And then it's a robot, so that's enough said. So the tech stack that I used Yeoman to pull down my initial template. I used the AngularJS generator for that. I used Bower and NPM for my client and node dependency management. I used Grunt for my build and development tools. Angular plus Bootstrap was my presentation. And then I used Typescript for some parts of the project that were more complicated OO parts. And then lastly, I used Cordova to enable it to run on Android and also to access the Bluetooth hardware. So, show of hands, who's used Grunt? Who loves Grunt? It's absolutely amazing. It is the ultimate utility belt. It's Node.js, works on Windows and Mac. It allows you to set up asset minification and bundling pretty easily. You can handle Alt.js and Alt.css watch compiling very easily to make it where when you change your TypeScript file, it automatically updates all your JavaScript. You can set up a local web server very easily with it. You set up JS hint for all your JavaScript, and it will help you run your auto test. And then I added a part to it to help me with building my Cordova project, and the main thing it does is it symlinks stuff into my www project so that I can just change it directly in native and it will just automatically change. So the architecture for this is pretty simple. You have the presentation layer that uses Angular Bootstrap, the Lego NXT API, which is actually all written in TypeScript, which gets transpiled in JavaScript, and that's what Angular references, the JavaScript file. And then from there, it talks through PhoneGap, and it sends byte array commands to the Lego NXT. And so the next part of the talk is to go through a few plugins that I used for this. The first one is a Bluetooth serial program or plugin, and it was authored by Don Pullman. This is just some of the API. It's just the pieces that I used. So it's connect, disconnect, read, and write. All right, so here's the code that I set up. And this is the connection.ts class. And there's a few interesting things going on here. So this first thing is this declare var window, and that's an ambient declaration, and you can use those to interface with JavaScript. And I'm just letting JavaScript know that the window object is going to be there, even though it's not actually declared. So that way you could actually reference, JavaScript and mix TypeScript, essentially, even though the objects aren't actually TypeScript objects.
Question, what kind of scope worries do you have to worry about naming a variable window when it's coming from web view, if any?
What kind of what now?
Do you have to worry about the scope from the web view in terms of like window as a global variable maybe?
Well, all I'm doing is letting TypeScript know that there's going to be a window variable.
Okay.
So that I can reference it at the bottom. And now I had a little problem with this presentation at the beginning. So at the top, we have the namespace. What this will do is enclose all the code in closure with NXT on it. It's like painting all weird things. It's like cutting it across both screens. Yeah, I just want to do it. Hey,
Unexpectedly.
awesome. I enjoy. It's like yes, but it's Zoom. All right, so be fancy with Zoom.
Control key. You might want to pull that last bit right there and copy something from the presentation over from
Wow. All right, well, I'm not going to actually run this code, so it shouldn't really matter. I'm not sure where my... Wow. Where my notes are.
control on the two fingers.
All right. Okay. All right, so the first thing is you can declare classes in TypeScript, which is kind of nice. That was why I chose to use TypeScript for the object-oriented part of the API. You can also have constructors, so we have a constructor down here. And this is where the ambient declaration came in hand, or I needed it, because I have to access the Bluetooth plugin off of the window object. So that was why I declared that at the top. The other thing is there's actually an interface up at the top for all of the connections. So we have a mock connection and a Bluetooth connection. And what we're doing is if the plugin isn't present, we're going to switch to the mock connection, which just logs what we're doing. And then at the bottom is where we actually make our calls to write the information to the robot and read the information from the robot.
So is this a plugin that you wrote for PhoneGap, or what?
So what happens is all of this TypeScript gets transpiled into one JavaScript file. And then that JavaScript file is the library, essentially. Does that make sense?
TypeScript is just it's like a superset of JavaScript. So someone didn't like the way JavaScript
Wasn't
right?
object oriented?
Right, exactly. So they created TypeScript, and then you run TSC TypeScript, and it outputs a JavaScript file. So this is all just like his preference to write JavaScript.
Got it.
You could do all this in straight, plain old JavaScript.
So the other thing that I've done that's a little different is I'm actually mixing the two. So I'm just using TypeScript for the API and for my model. Because those are the two things that typically have the most business logic or are the most complicated and persistent. But like the Angular controller and stuff like that, I'm just writing in JavaScript. So I'm not writing everything in TypeScript, just the pieces that it made sense to, because I wanted to be able to do inheritance and stuff like that, which is just a little bit cleaner using an alt.js language. So the next class is the brick, which represents the Lego brick. And here we have getters and setters. So you can actually declare a getter and a setter. And what will happen is when the JavaScript gets created, it will actually, whenever that variable is set, it's going to call the setter. Whenever you do a get, it's going to call the getter. And then another feature is these static variables at the top. So you can declare things static, and then they end up being static. So if you were in JavaScript, this would be NXT, which is the namespace, .motor, .modes, .on. So it would automatically put it as a singleton.
What's the difference between the public and the private in this case?
So public means everyone will be able to see the variable in TypeScript. But obviously we know JavaScript doesn't really hide things, so it's not going to be really hidden. But you can still encapsulate things using that. If you're using another TypeScript class, it won't be able to see the internals of the other object. So that's what, it's very much the same as an OO language. And then the other part is the sensors. So in the sensors, we actually have inheritance. So the sensor is the base class. And then we just tell it we want to extend. So the I2C sensor extends sensor, and then the sonar sensor then extends the I2C sensor.
And are the sensors just to keep it from running into walls or other objects, or is there more to it?
The sensor, so the ultrasonic sensors can tell distance, so you could keep it from running into a wall. You could have it do avoidance, so it try to go across the room. If it sees an object, then it tries to go around it. And that's the kind of stuff that I was wanting to work on with my son with this. So,
How are you communicating? Is it Wi-Fi? IP?
it's Bluetooth. So I'm talking to the robot with Bluetooth through PhoneGap. All right. So the next thing is the Accelerometer Plug-In. I'll go ahead. So what I did was basically implement tilt control with the accelerometer.
Is the source available?
Hmm?
Is the sources available?
Yes, it's on Git. Okay, so for this one we're going to turn on, so everybody, controls on the right, the floor on the left. So basically tilt it forward, it goes forward. Tilt it to the left, it's going to go left. And then backward. So that was what I did with the accelerometer. For this one, the API is pretty simple. The one that I used, you just tell it you want to watch acceleration, and then you pass in a frequency, which is how often you want it to update. And that returns a watch ID. And then if you want to stop listening, you can call clear watch. So this is my controller. And in here is where oh, no, that's not. Sorry. This was the model which I actually was supposed to show you a minute ago. I'll just go through it really fast. So in this, it's basically just shows how you're using the API. You're wiring up each port with sensors. So you're saying, at the top you're saying, create a new motor, and then assign it to port A. And that's basically just wiring up the brick. And then for movement, most of them, they end up calling into this function, which is move, which tells the motors how much power you use, and then we write to them. And then the read sensors, this basically polls all the sensors in sequence, and if it fails on reading, it just goes and reads the next sensor. So it's just a little chain. And what's happening is when the controller is updating the sensors on the robot, it's going into like a polling loop, and it keeps on looping with the robot, pulling the sensor values and then updating the UI. So here's the tilt example. The UI actually calls toggle tilt, and what that does is if I already pressed it, it's going to cancel the watch and basically stop it. And then at the bottom is where we're calling watch acceleration. And then we give it a frequency of 500, and then that ends up calling our code at the top for success. We just check to see if there was enough change. If there was enough change, then we look at how the device is tilted, and then that's how we decide what to do with the robot. So that's okay. And then one more example, which is speech to text. This was a community plug-in by Simon McDonald. He worked for IBM. The API part that I use is you can create a new speech recognition, you can tell it to start listening, and then there's callbacks for a result or an error. And then you can tell it to stop when you're done. So, go, stop, right, stop, left, stop, back, stop. So that was the voice control part. All right, so the code for that, it has a similar toggle to the way tilt worked. And then here we're creating the recognition class instance. We listen for a result, and then when we get a result, we do a voice match. We basically look, when a result comes back, it comes back with a bunch of possibilities. We're just looking through all the possibilities and seeing if it's a match. And then at the end, this is how it gets, where it loops, so it keeps on listening. If it succeeds, then it starts listening again. If it errors out, then it starts listening again. So it will keep on listening to you. And that's why you kept hearing a beep. That was basically when it was starting to listen.
Matt, does that use Google's text-to-speech engine, or does that use its own?
It's using Google stuff.
Okay.
Yeah.
Does it understand accents?
I don't know. You can try if you want. So that was all the PhoneGap stuff. I had some more stuff, but I'm running out of time. Just a quick plug for, let me actually put this up here. For Robots Comp, I actually went there in December. I would highly recommend anybody that wants to learn anything about robots to go there. And I had, this was the little robot that I built there. It was an Arduino. And then this is what I'm working on right now, which is like an Node.js rover. I'm using Raspberry Pi with an Arduino. And there's actually an adapter board that allows you to use the two together. And then you may ask, why would you do that? Well, it's because then you can use all the Arduino sensors. So I can use the sonar, the GPS from Arduino. I can use the Raspberry Pi camera. I can put Node.js on the robot. So it should be a pretty good platform to build something on. And my name is Matthew Ronemous. Thank you very much. Thank you for your time.